Okay, so what we're going to look at now, guys, I need y'all to stop talking. What we're going to look at now is a few examples of how to put things in standard form, and we'll talk a little bit about how you do that. And again, it's really not that difficult. We just need to get a little practice with it. So we'll look at a few examples from your sheet. So if you've got it with you and you want to turn it over, and that way you can kind of follow along and make notes on it, that would be a good idea. If you don't have that worksheet with you, I do have a few extra copies, or you could always just write things down on blank paper like I did when I was a kid, because my teachers didn't give me notes. So anyway, let's see. The first example, number 1, was 2y equals 7x minus 6. Now, first thing you need to know is standard form looks like ax plus by equals c, where a, b, and c are all whole numbers, and a has to be a positive whole number. Okay? So in other words, something that's in this form could be, 3x minus 2y equals 7. It could be anything as long as the first number is positive. The second number, it can be plus or minus. In other words, it can be a positive or a negative. And then the last number can be positive or negative. But they all have to be whole numbers, and the first one, the one that's attached to x, has to be positive. So those are your only rules for putting things in standard form. Yes?
Miss Jackie said that it could not be in fraction form.
That's what I said. I said it has to be a whole number. All right. So let's look at this example. So the first thing, if I know I need to have something in x and something in y, the first thing I need to do is move this over there, right? Because x is currently on the side with a constant, and I really want x on the same side as y. So how do I get 7x from the right-hand side to the left-hand side? Hannah?
You subtract 7x from 7x from constant.
Right.
And then you subtract it from 2y, and then they're not like terms.
Right. So I'm going to subtract 7x from both sides. When I subtract 7x from 7x, it goes away. 7x subtracted from 2y, like Hannah said, they're not like terms, so we're going to have to leave them separate. One thing here, I don't want 2y minus 7x. I want negative 7x plus 2y. Because again, that standard form is ax plus by. So you want your x term first, your y term second, and then your constant on the other side, right? So we want to put the variable, our x term first. So since it's minus, that'll make it negative, and since 2y is positive, that will make it plus, right? Then from here, the only problem with this being standard form is that it is currently negative 7x, right? And we need positive. So, simple way to take care of that is what? Multiply both sides by negative 1, or divide both sides by negative 1. Either way, you're doing the same thing. So, if we multiply by negative 1, the important thing to remember there is you're multiplying the whole side by negative 1. So it's not just negative 7x times negative 1. It's negative 7x times negative 1 and positive 2y times negative 1, right? And really, it's pretty simple because all it's going to do is change all of your signs. This is currently negative 7x, so it will become positive 7x. It's currently plus 2y, so it will become minus 2y, right? And then on the other side, it's negative 6, so that will make it positive 6. So essentially, just all your signs are going to change. And now we have standard form. Ax, where a is a positive whole number. By would be negative 2. Y, and then C is 6. So this is now in standard form. All right, so let's look at the next one on here. So for this one, I have negative 3x equals negative 13y plus 2. Yes, Zach?
Add 3 from 3x to 13y.
All right, you're kind of making more work for yourself by doing that. It's not going to be wrong, but can anyone tell me what would be, Tanner's had his hand. Let me,
You put the negative 13y on the other side by adding.
yes. Okay. All right. So why is that a better move than what you first suggested, Zach?
Oh, because then you'd have to do plus 2.
Right, because if you move the x over there, then you've got your x and your y and your constant all on one side. And really you want to move the one that's with the constant, so that way you already have x, y on one side and constant on the other. So I want to look at, okay, here's my constant, so I want to get rid of that over there. So it's plus 13, it's negative 13y, so I'm going to add 13y. On this side it cancels. And then I have negative 3x, remember x term still comes first, plus 13y equals 2, right? Is that in standard form?
No.
Why not?
Because the x
X is negative.
All right, so once again, I can multiply this side by negative 1 and multiply this side by negative 1, and I get positive 3x minus 13y equals negative 2. And again, just the signs changed. It was negative 3x, so it became positive. It was plus, so it became minus. It was positive, so it became negative. So multiplying through by negative 1 changes the sign of everything involved in the problem. All right. So now let's look at one that has fractions, because that's the one thing that's a little bit different. So let's look at number 4. So this one we have 3/5 x minus 2 equals 4y. So I'm still going to start out the same way. If I want it in standard form, that means I want x and y on one side and my constant on the other. So what would be the easiest way to do that?
3x. Or 3.
Okay, move 3/5 x. And since it's positive, that means I'm going to subtract it. On that side it goes away, so I have negative 2 equals, I want my x term first, so negative 3/5 x, and it's positive, so plus 4y, right? Now technically, since we want it in standard form, you can rewrite it as negative 3/5 x plus 4y equals negative 2. That way it's x, y, and c on the right-hand side. Okay? So all I did there is just swap which side is equal sign. But now there's still some problems with this being in standard form. What are the problems? Okay, my x value is negative. What else? Kaylee?
X value is a fraction.
Okay, so my coefficient for my x has to be positive, and my coefficient for all of my variables has to be a whole number, right? All right, so there are two things that we're going to do in section 4.3, which are, we're going to learn how to graph a linear equation using a t-table, and we're going to learn how to graph a linear equation using x and y intercepts. One of the main reasons I wanted to start with how to get things into these two different forms is because each of them makes one of those a little bit easier. Okay, if I'm going to have things in a t-table, I want it in that slope-intercept form. Okay, because it's just much easier to plug in values that way. If I'm going to graph using an x and y intercept, I want it in the standard form. So like I said, each of them has a different advantage. So let's talk for a second, though, about simply what is a linear equation, because we've gotten this far in the chapter on linear equations and really hadn't talked about it. So let's start with just a simple one. All right. A linear equation is basically an equation that has are, that we've seen so far that has two variables, okay, an x and a y. Does anyone know why it's called a linear equation? Tanner?
It has to do something with a line.
Good guess. It does have something to do with the line. If I give you this equation, how many solutions are there to that? One, right? If I say x plus 4 equals 8, then x has to be 4, right? No doubt about it. There's only one possible solution, okay? But when we get to equations that have two variables, how many solutions does that have?
A million, anything.
Okay, it has an infinite number because, I could say, all right, let x be 4, then y would be 4, and you got 4 plus 4, which equals 8. That's a solution. So I could do 4 plus 4, but I could also do
-8 plus
3 plus 8, or I could do 8 plus 3, because that's really a different solution, right? If x is 3 and y is 8 versus y is... Oop, no, I meant 5. Sorry. End of the day. I'm getting tired, obviously. Yeah, not 8 and 3, 5 and 3.
6 and 2.
So we can do that. You could do, 6 and 2. You could do 8 and 0. Negative 2 and 10. Negative 180 plus 188. Right? I mean, obviously, and then that's only whole numbers. I mean, we hadn't even gotten into, well, you could have, 4.5 plus 3.5, right? Okay. So, obviously, there are an infinite number of solutions to this equation, right? So, if someone asks you to show the solutions to this, you can't just list them, because that would take the rest of your life and you still wouldn't be done, okay? But here's the really cool thing. Let's look at a graph.
You can just
Draw a line.
Now, if I look at this graph, and let's do a line here. All right, so if I have this and I start putting these solutions on my graph. So let's see. We have 4, 4, so I could go to the right 4, right? X is 4 and y is 4 is a solution, right? So that's the ordered pair 4, 4, which means the right 4 and up 4, which puts it right here. Thank you, ma'am. Then I also have 3, 5, right? So I'm going to go to the right 3 and up 5. But I also have 5, 3, which means I go to the right 5 and up 3.
make a line. Make
Ah.
a circle.
All right, and then we have 8, 0. So I go to the right 1, 2, 3, 4, 5, 6, 7, 8, and up or down 0. Yeah, I'm just picking a few of them. All right, you've got 6, 2. That's there. All right, do we notice anything about the points that we put on there? All right, it's this straight line. Every single solution, even the decimal ones and the really big, crazy, negative, huge, positive ones, every single solution that will work for that line, for that equation, is going to be on this line right here. Every single solution. Okay, this is why this unit is called linear equations, because all of these equations can be represented by a line that shows you every single pair. If not only can every solution is on this line, but if I pick a number off this line, like if I look right here and I say, okay, that's 1, 1, 2, 3, 4, 5, 6, 7. Does 1, 7 work? If x is 1 and y is 7, 1 plus 7 is 8. Okay? Not only is every solution on this line, but anything that's on this line is a solution to that. Okay? And a line shows infinite solutions because a line goes forever in both directions, right? So this shows every single possible solution, and the only things that are on this line are solutions to that equation. Yes, Cam?
Wait, but like, wouldn't
-2, hang on. -2, we go 1, 2, and then up. Hang on, let me switch back to my pen. So I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I extend that line out, there we go.
Our line's kind of crooked.
Yeah, my line is a little crooked. It's easier to do it when I got a ruler, but that's going to go through that point as well. 4.5, 3.5. If I go to the right, 1, 2, 3, 4.5, and I go up 1, 2, 3.5. Again, line's a little crooked. I can't do it as well with this as a ruler, but you know, if this line were nice and straight, it would go straight through the middle of that square. So every single solution will be on that line. Okay. So when we get to graphing linear equations, now obviously to graph it, you don't want to find every single solution and then make a line and then connect them. How many points do you need to make a line?
2.
2. If you have 2 points, you can make a line, right? Okay. So a couple of ways that we can do that. The first way we can look at is graphing using standard form. If our equation is in standard form, there's a couple of things that you can do with that. One thing we can do is we can find our x-intercept and our y-intercept. Now, x-intercept and y-intercept mean if I have a graph and I have some lines, so let's do this line here, and I'll do another line over here. And then I'll do one more line right there. All right, so here we have a few different lines, right? Now, the x-intercept is where the line crosses the x-axis. So our x-intercepts and these that we're looking at are this point here, and this point here, right? All those little yellow dots, those are our x-intercepts, right? Because that's where it crosses the x-axis. Now let's look at the names. Now, my last class was very confused when I asked the names. The names of the points are, if you were telling someone to graph that point, what would be the name of this point? It's not Bob or Sally, it's a coordinate, okay? So what are the coordinates of this?
-4, 0.
Okay, -4, 0, right? Because we start by going to the left, 1, 2, 3, 4, and then we go up or down, none, right? So this coordinate right here is -4, 0. All right, what about this one here? What's the name of that place? Emma Grace? 3, 0, right? And then we have one more right here. What would be the name of this one? Addison?
4, 0.
What is it called?
I know. Don't you wish your parents had named you that?
4, 0.
Yeah. Hey, my name's 4, 0. What's yours? All right. So, what do you notice about all of our x-intercepts? Jake? Okay, what do you mean by they're graphed on 0?
They're on 0x.
Now 0x.
That would be 0y.
0 is y. Okay, why is it that your x-intercepts have a y value of 0? Tanner?
Because they go across the y. That's where they go across the y-axis, and if it's on the x-axis. So if it's on the x-axis, it has to be 0y.
Okay. Y tells you, your y coordinate tells you what? How high or low you go, right? So if you have a positive y value, that means you are that many numbers above what?
The x-axis.
The x-axis. And if you have a negative y value, that tells you you're that many below the x-axis. Which means if you have a 0, you are neither above nor below the x-axis, which means you are on it, right? So the first thing you need to know is for an x-intercept, the y value has to be 0. James, you need to wake up and pay attention to me. All right. Now, the y-intercept, that's messy. It looks like an x-intercept there. All right. For our y-intercept, well, let's look at our y-intercepts for these same points. So our y-intercepts, of course, are being the places where it crosses the y-axis, which would be down here, right there, and on the blue line up there. All right, so let's talk about their names. So who can tell me the name for this one on the blue line right here? Jake? Oh, can somebody go shake the mouse on my computer? That's the one thing I don't like about teaching in this area. It times out my computer. Yeah. All right. All right. All right, Jake, if you'll go back to telling me what's the name of this one right here. All right, 0, 5. All right. Who can tell me this one right here? James?
0, -2.
Good. 0, -2. And our final one down here, our last y-intercept. Brian? 0, -6. All right. So what do we notice in common about all of our y-intercepts? The x value is 0. Now, why do you think the x value is going to be 0 for all of them? Cam? Okay, but why does that make the x value 0 if it's on the y-axis? Can it ever be on the y-axis and the x value not be 0? No, why not?
Well, it could be at 0, 0.
Well, your x would still be 0. Your y would just be 0 as well. Okay, because your x is telling you to go to the left or to the right, and if you're in the middle, you have gone neither, right? So that means your x value would have to be 0, right? The first thing you do when you're graphing is you go left or right. So if your x value is 0, that means you stay there, and then you just go up or down, which means you're going to be somewhere on the y-axis, right? So it's kind of backwards because in order to find the y-intercept, we have to let x be 0. In order to find the x-intercept, we have to let our y value be 0, right? Now, this is where standard form is going to be more helpful, okay? Because let's look at finding x and y intercepts in standard form really quickly. So I'm going to take some equations that are in standard form. So let's say I have (3x plus 2y equals). Let's do this. I'm going to give it whole number answers. Let's make it 12. All right. If I want to find my x-intercept and I want to find my y-intercept, what do we know, what did we just discover about the x-intercept and the y-intercept? Tanner?
The x is 3. And the y.
No? No? What do we know about our x and y-intercept? What do we know about our x-intercept and our y-intercept?
The x.
The opposite value has to be 0, right? So, if I go into this, if I want to find my x-intercept, that means I want my y value to be,
Minus 0.
okay? If I want to find my x-intercept, then that means y is 0, right? So looking at my equation, I have 3x plus 2 times 0 should equal 12, right? I just replaced y with 0 because my x-intercept is where y is 0. So I'm going to let y be 0. Well, the nice thing about letting that be 0 is that just goes away, right? 2 times 0 is just 0. So basically I just have 3x equals 12. In other words, I have that equation up there, right? And if 3x equals 12, then what does x equal? 4, right? All you have to do is divide 3 by 3 now, and you get the x-intercept is 4. Specifically, though, remember a point is an ordered pair, so my ordered pair would be what? X is 4.
4, 0.
Y is 0, right? So this would be our x-intercept for this line. Now our y-intercept is where x is 0, right? So it's just the reverse. Instead of scratching out the plus 2y, here I'm going to let x be 0, which means that that goes away, right? Because 3 times 0 is just 0. 0 plus 2y is just 2y. So I get 2y equals 12, which means y would equal 6. So this ordered pair would be 0, 6. Because this is my y value. My x value is 0. So I have 4, 0 and 0, 6. And then if I wanted to graph this linear equation, all I would have to do is graph those 2 points. So I have 4, 0, so I'm going to the right, 1, 2, 3, 4, and up or down 0. So I have that point. And I have 0, 6, so I'm going to the left or right, none, and up 1, 2, 3, 4, 5, 6. Those are my x and y intercept, which means my line looks like, oops, not like that. Looks like that. So this line would show me every possible solution to the equation 3x plus 2y equals 12. Anything that's on this line, anywhere where it crosses a point exactly, like this right here, you see this number right here, where it crosses. Now you have to be careful, it has to cross exactly, but if you look, do you see that point right there? Okay, the value there is 2, 3. Right? So let's check. Does that work? If I have the equation 3x plus 2y equals 12. So that's 3 times 2
6.
plus 2 times 3 equals 12. Is that true? Yeah. Okay. Any other point that you find on that line will satisfy that equation. Okay? But you don't have to find every solution. All you have to do is find your x-intercept and your y-intercept, and those two points will create a line, and that line is the solution to that equation. Now, we'll go into this more in depth tomorrow, but that's just a little introduction, and we'll talk more tomorrow about why the y equals form. Thursday, that's true, not tomorrow. Field trip tomorrow. So, all right.
Wait, what time?